Welcome to True Projects. In this video, we are going to explain about the project that is an edge computing based and threat behavior aware smart prioritization framework for cybersecurity, intrusion detection, and prevention of IEDs in smart grids with integration of modified LGBM and one class SVM models. So, before getting into the execution, first let us understand what is the project about. So, smart grid. It is essentially a modern update to the traditional power grid designed to make the way we produce, distribute, and consume electricity much more efficient and reliable. Think of it as a network that uses advanced technology to improve the entire electricity system. One key part of this is the use of intelligent electronic devices that we call as IEDs. So these are intelligent electronic devices which include things like smart meters. These meters provide real-time data about how much electricity is being used, allowing both the consumers and also utility providers to track and manage energy usage more efficiently. It's a two-way communication. So utility companies can send important information back to consumers via and vice versa. Additionally, Additionally, smart grid integrates renewable energy sources like solar panels and wind turbines, which are becoming more common as we move towards cleaner energy. The control system in the smart grid are designed to handle the fluctuations that come with these renewable sources, ensuring that energy is distributed efficiently even when the supply from renewable varies. So there are also energy storage systems like battery built in the grid. This helps to balance the supply and demand by storing energy when it is abundant and then releasing it when it is needed, ensuring that grid operates smoothly and efficiently at all the times. In short, the smart grid is more sustainable, efficient, and reliable version of our traditional power network designed to meet demands of modern energy conscious world. So when with all the advanced technologies and interconnected devices, we do have some problem in the smart grid. So with these all the advanced technology and interconnected devices in the smart grid, the system has become more complex and that complexity brings new challenges, particularly when it comes to the security. Since the grid relies on many devices working together, it becomes vulnerable to various types of attacks like unauthorized access, data manipulation, or other intrusion attempts. If these attacks are successful, they can mess with the critical parts of the grid like the smart meters, that is IEDs, or the communication network. This could lead to service interruptions, data breaches, or even financial losses, all of which would greatly impact the grid's reliability and stability. And what makes the problem even worse is that fact that the smart grid is distributed and dynamic. It is not like traditional centralized network where you can easily monitor and secure everything from one point. Because of this, traditional security methods just don't cut it anymore. So we need more advanced solutions that can detect and stop attacks as they happen. These solutions should be able to identify potential threats before they cause significant damage, improving the overall security and ensuring that grid continues to run smoothly and efficiently. In short, there is a clear and pressing need for stronger cybersecurity, the smart grid to handle these issues. So, to overcome with all these issues, this project is designed to protect smart grids from cyber threats using machine learning. So, the system uses two key machine learning models. So, the project proposes to use machine learning models and that to specifically two machine learning models that are light gradient boosting, that is LGBM, and one class SVM, that is one class support vector machine. Now, LGBM is really good at detecting complex patterns in the data, so it is used to spot more sophisticated threats that might try to mess with the grid. On the other hand, one class SVM is used to recognize when something familiar or known goes wrong, like an intrusion that happened before. It is designed to work for both the binary, where there are just two possible outcomes, like there is intrusion or no, I mean, there is attack or no, and we will also be doing multi class classification. So these two models are built for both the binary class classification and multi class. Binary, it refers to whether there is attack or not. Here, multi class refers to which type of attack it is or there is no attack. So those two models are compared for both the classifications that are binary and multi-class. So together these models make up a solid defense system against cyber threats, making the grid more secure and resistant to potential attacks. Alongside alongside with these two models, we have also used other traditional models like support vector machine, that is SVM, and gradient boosting. And these all are put put in a place to compare their performance against the newer models to evaluate how well each model performs. And we look at several important factors such as accuracy, precision, recall, and FN score. So these are the metrics used to evaluate all the models trained in this project. These metrics helps us to measure how effectively the models are able to detect and classify intrusions in the grid. By comparing these various models, we can ensure that our approach improves the best possible protection against cyber threats in the smart grid. So this is a proposed system. Now moving on to the extension. To further improve the accuracy of the project, we are incorporating an ensemble method, that is stacking classifier. This method works by combining the predictions from several different models to make a final decision. Think of it like getting advice from multiple experts instead of just one. So by doing this, we can harness the strengths of each model, making our system more accurate and reliable. It's like putting together a team of specialists where each one contributes in their own way to improve the final outcome. And we have also developed front end using Flask framework. So this will make the system more user friendly by allowing people to interact with it directly. Users can log in into the system using authentication, ensuring that information is secure. This will also give us a platform to test how well the system works in different scenarios and gather the feedback from others. So this is the extension part. Now coming to the implementation. To implement this project, we have followed the steps mentioned in the flow of work. So first, we have imported all the necessary libraries such as pandas, NumPy for data manipulation, scikit-learn for machine learning, Seaborn and Matplotlib for visualization, and etc. Then comes exploratory data analysis part. So next we dive into the data set to understand its structure, identify any patterns or inconsistencies, and get a sense of the data we are working with. And then comes data pre-processing that involves removing duplicate data and drop cleaning. Coming to removing duplicate data, so here we check for and remove any duplicate entries to ensure the data set is clean. Then comes drop cleaning. Here we remove irrelevant or unnecessary columns that don't contribute to the prediction. After pre-processing, we do data visualization. We use visual tools like graphs and charts to get a better understanding of the data distribution, correlations, and patterns. Then comes label encoding. So here, for categorical variables, we will be converting them into numerical labels so that machine learning models can process them. Because machine learning models will be only taking the numerical features as input, numerical variables as input. Then comes feature selection. So here we select the important, most relevant features from the variables that contribute to the most of the prediction, improving model efficiency. Then we split the data into train and test sets, where train set is used to train the model, validation set is used to evaluate the model. Then we initiate all the machine learning models that we are building that will be initiated for both the multi-class and also binary class. Then, then the models are trained using the training data where they learn patterns and relationships in the data. And we evaluate all of them using accuracy, precision, recall, and FN score. So these are the metrics used to evaluate them. And all of them are compared through the graphs. Then comes the part of front end. So the system uses interface, which is developed using Flask framework. This includes setting up an user registration and login functionalities backed by an SQLite database for storing user information. And in the front end users, they will be able to provide input feature values. I mean, they will be giving attack related values, and then we will be predicting that values. So that given input, it will be pre-processed at the backend. It will be fed with a trained model. Finally, outcome will be displayed through the front end of the application. So this is how we have implemented the project. Now moving on to the algorithms used. These are the algorithms used in this project. This is the proposed model, and this is also the proposed model. This is the extension model. And these are the models trained on the dataset for predicting the attacks. And to implement this project, we need basic requirements, which are hardware and software. Coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute, we're supposed to open the code folder that contains source code files. So let's open the code folder of the project. So these are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? So here in the archive folder, we have the data set used in this project. Let's open this train file. In this only the data set we have that is used to train the models. So these are the different features. So here you can observe, right? Here we have multiple features. So we will be using this entire data set to train the model for predicting the attacks. So we will be selecting most important features from these and then we will be training the model. Let's close this. Before closing, let's see. Here is the target class where we have multiple classes here. So here these are the different types of attacks we have in this project and we will be predicting them. Close it. So here in this test file, we have the data that we will be using for testing how the model is performing. So train model is used to train the model. Test set is used to evaluate the model. Let's get back. And here in the static folder, we have CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here in the templates folder, we have HTML files that are used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. These are the two model files in which we have algorithm information stored that will be loaded into the project code during runtime of the application. And here we have notebook file. So this is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the sample file in which we have test cases and that is saved in the text document. And this is the signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. I've copied it. Now open Anaconda prompt. It has been opened. Give the command cd, give the space, paste the copied path. Now click on enter. Here, if you observe, current directory is changed to the code folder's path. Now, we are supposed to compile app.py file. So give the command python space app.py. Now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host. This is the local host and the port unless configured differently. So copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. We need to get signed up first. Click on sign up and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in and give your username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. So these are the selected important parameters. So initially we had so many parameters, right? So after selecting the most relevant features, these are the features retained. Based on these features only, we will be predicting the attacks. Now let's understand what are these. So the first one we have is the SQ num, that is a sequence number. This is a unique identifier for each message or data entry in a sequence used for tracking and ensuring data integrity. Then we have ST num, that is station number. It's a unique identifier for specific station or location within the system. This helps in identifying which station the data is coming from. Then we have state CB, it is the circuit breaker. It refers to the current state of the circuit breaker, whether it is open or closed, indicating whether the circuit is active or deactive. Then we have SQ difference, that is sequence difference. It represents difference in the sequence numbers used to detect gaps or irregularities in the data stream. Then we have ST difference, that is station difference. This indicates the difference or variation between two stations, possibly used to detect discrepancies or abnormal reading between them. Then we have time last message, that is the timestamp when the last message was received. This helps in tracking the freshness of the data and identifying delays or issues in the communication. Then we have recent change. This is the flag or indication of any recent changes in the system, such as modification in settings, statuses, or other parameters. Then comes the part of consistency. So it refers to whether the data is consistent within the expected patterns or values, and it is used to check for anomalies or errors in the data. Then we have MU1 log, that is a log of the first measurement unit, typically containing data or status information related to the equipment or device. Then we have three-phase CMU2. This refers to three-phase measurement or control unit 2. It typically used to monitor or control three-phase electrical systems. Then we have mu2 current angle B. It is the current angle of the second measurement unit, that is mu2, which refers to the phase angle or orientation of an electrical component. Then we have mu3 current angle B. Similar to mu2, this refers to the current angle of the third measurement unit, indicating its phase or the position in the electrical system. The last one we have is any relay. So it refers to the status of any relay in the system, indicating whether the relay is triggered, opened, or closed, which is important for controlling electrical circuits. This is all about the parameters. Now let us enter them. So let's open the sample file. So let's enter the values. So these are the test cases that we have. And here in the last column, we have the target class. So let's apply filter to class 0. Click on OK and enter the first case. So let's enter the first test case where sequence number is 1, ST is 2, state CV is 1, and SQ difference is -3, ST difference is 1, 319, it is time last message, and then we have recent change that is 1, consistency is 0, MU1 log is 1, and then we have three phase MCU CMU2 that is 0, and then M2 MU2 current angle B it is also 0, and the next one is 179.84 that is M3 current angle B, and then any relay is 1. Click on predict. So this given input, it will be pre-processed at the backend and then train model will be giving us a prediction. So here we got the prediction that there is an attack detected. It is anomaly, that means there is an attack, and here that attack is fault attack. So here you can observe that fault attack has been detected. Now let's check with the class 1. So total here we have 5 classes, that is 5 types of attacks. In that, one including will be normal attack. That means there will be no attack. Let's click on prediction. So here, let us enter this case where SQ number is 27, ST number is 56, state CV is 0, 22 is the SQ difference, 49 is the ST difference, and then we have text message, text last message, that is time last message, that is 943. Recent change is -1, consistency is 1, 0 is MU3, MU1 log 3, and then we have three phase CMU2 is -19.84, and then MU2 current angle B is -65.15, and MU3's angle is -65.58, and any relay value is 0. Now let us click on predict. So here we got the prediction that there is an attack detected, that is anomaly. There is an injection attack. So here there is an injection attack. Now let's check with the class 2, apply filter to class 2, click on OK. And now let's enter this case. Click on prediction where sequence number is 7, ST number is also 7, state CV is 1, SQ difference is 0, state difference is 1, time last message is 0, recent change is 1, consistency is 0, and then MU1 log is also 0. And then we're supposed to enter three phase CMU2 that is -3.32. MU2 current angle B is 132.53, and then 137.880. Now click on predict. So here we got the prediction. There is an attack detected. It is anomaly. So here masquerade attack has been detected. Masquerade attack has been detected. You can observe, right? Now let's apply filter to class 3 and check with that. Click on prediction. So let's check with this case where SQ number is 4, ST num is 1, 0, 2, -46, 929, 0, 1, 0, and then -2.33, 122.87, 122.85, 0. Click on predict. So here we got the prediction. There is no attack. So here it has been predicted as normal case. So here class 3 refers to normal. Now let's apply filter to class 4. Click on OK. Let's try with this case. Click on prediction. 3 1, 0, -10, -6, 319, -1, 1, 0, -1.25, 29.15, MU3 current angle B, it is 0, 1. Now let's click on predict and see what will be predicted. So here we got the prediction that there is an attack detected and that attack is replay attack. So here you can observe that replay attack has been detected. So this is how you need to execute. Now let's check the graphs. Click on graph. So the first graph which we have is the correlation matrix graph. So this is the correlation matrix graph which shows the correlation between variables. And here we have multi-class sample outcome graph. Here on x-axis we have all the classes that we are predicting in this project, and on y-axis we have count of that class. So you can observe, right? And here this is the accuracy comparison graph. Here on x-axis we have accuracy score, and on y-axis we have all the algorithms that are trained. This is the precision score, this is the recall score, and this is FN score. And these all graphs are for the multi-class classification. These are graphs for the multi-class classification. And again, here we have for binary class where we will have only two classes, that is anomaly and normal. And here accuracy, precision, recall, and FN score. Now click on sign out. So in this way, just by giving input to the application, what it will happen is first it will classify binarily, that is whether there is attack or not. If there is attack, it will classify which type of attack it is. If the attack is detected, it will classify which type of attack it is. If there is no attack, it will just show that there is no attack. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.